measurement, some best practices I've seen in how to implement it, and fairly controversial or possibly controversial proposals for how to adjust productivity for quality issues. First, let me introduce Sisk. The Consortium for IT Software Quality was formed as a joint sponsorship by the Software Engineering Institute at Carnegie Mellon and the Object Management Group. The initial objectives were to be able to create some definitions for structural measures of software that could be computed at the code level. So the goal here in the beginning was quantification of things like software quality, software sizing, and other kinds of critical parameters for software management. When we formed this, we had 24 companies join in, and you can see on the list of companies here some large IT organizations in various industries. You can see a number of large system integrators and outsourcers. You can also see some small companies that provide tools and technologies and services into the IT market. So it was a very good mix of companies to help initiate the effort to define initially measures of software quality and sizing. In fact, these were the initial objectives that were decided at some forums we held for executives of companies that were interested in joining Sisk. We asked them what software quality measures, what software sizing measures would be most valuable to them. These were the 5 that they listed after we voted through a whole series of different measures. They wanted automated function points and then the 4 other software quality characteristic measures of reliability, performance, efficiency, security, and maintainability. We've finished the set of first objectives. In fact, the automated function point spec has now gone through the OMG process for approval as a supported specification of the Object Management Group. So it is available. We're finalizing that document. It'll be available on the OMG website shortly. We have a Sisk document for the definitions of the other 4 quality characteristics, which you can get in the members area of the Sisk website. I encourage you to join Sisk if you're not already a member. It's free. You can just go on the website, and inside you'll find a number of hopefully very valuable documents and other kinds of information and materials. So once they go through OMG, then they become defined measures. We're holding deployment workshops at the various OMG technical meetings quarterly. I'll tell you more about that at the end, and we'll move some of these over to the fast track at ISO. So this is what we're working on now. We'll be moving the 4 quality characteristic measures through the OMG process very shortly, but the automated function point specification is now supported specification of OMG, which means we can start using it as a foundation for doing sizing and productivity analysis. This is the sort of the image of the specification. The important thing about this is, in terms of an automated specification, it gives us a consistent way to count function points. It's automated, therefore over time it becomes much cheaper, and it allows us to shift the investment from counting to improvement. I think, frankly, that's the most important benefit of this specification, is once we automate this and start making the counting aspect cheap and fairly straightforward and a part of an automated tool set, then we can really spend the cost, move it from manual counting to the actual improvement program itself, and using this in productivity analysis and using productivity analysis to guide improvement. So let's now move into the body of the presentation and talk about productivity analysis itself. There's 4 major objectives we've seen people drive using productivity analysis, the most important typically being improvement, to look at what's limiting productivity, what kinds of things can increase productivity within an organization, and then continue to monitor that over time to make sure that they're trying to drive forward with improving the productivity and quality of the software that they're building. Now, as part of that, people typically use that as a way to improve their estimation, to be able to estimate the cost of future projects based on current productivity. Estimation is usually a relationship between size and effort, and as productivity improves, that set of parameters will shift. So estimation becomes very important, and as an organization improves its ability to build software, they reduce the variation in the estimates they can create. So improvements are a very important part of helping improve the overall estimation process. But productivity is a critical factor in estimation because it's the productivity, the factors that drive productivity that are often used to adjust the relationship between size and effort. In addition, then, that allows us to start creating benchmarks. Once we have a reasonably stable set of productivity parameters, we can start benchmarking and tracking against that. We can compare that to industry to see how we're performing against other IT organizations in our same industry or other outsourcers. Most importantly, though, benchmarking is typically best done internally, to where we're looking at our own benchmarks to see if we're steadily improving over time and how those benchmarks differ at different places in the organization and for different types of applications. I'll talk more about that later. And finally, it's used for managing vendors. It's used in the selection process if we can get some data to sort of calibrate how good vendors are, how productive they are. It's then used even more importantly in managing the relationship with vendors to help them set targets for continual improvement so the benefit we get from an outsourcing relationship continues to improve over time. So these are the four major objectives we've seen people set in trying to use productivity analysis. I'll probably focus in this seminar most on improvement because that tends to drive all the others. That we're going to talk about that you need for doing good productivity analysis. Most people think I only need size and effort measures. Actually, to really do this well, you need also to add some adjustment measures for quality and for the demographics of your various applications. So we'll talk about the various measures in these four categories that are available and that you have to choose from. But to really do a good job of productivity measurement, you need the primary measures of size and effort that have always been a part of productivity equations. But you also need to be able to adjust those equations with measures of quality because you can obviously create something very quick if you create it very poorly. And so we want to be able to adjust a productivity measure to look at how it affects quality and then to see how it differs across the various demographics in our organization, the application types, the locations, languages and technology platforms, and other kinds of things that would affect the productivity we're able to obtain.
Hey, Bill?
Yes.
Are you supposed to be on the slide with the Sisk objectives and processes?
No.
Okay, because that's what we're seeing, so I just want to make sure.
We're going to have to run with you. I think we're going to have to see now. Same thing?
Yeah. Hang on.
Okay, you're going to have to run it. I guess we're going to have to run it from your side, I guess.
Not a problem.
Can you see my screen now, my soft?
No.
Okay, yeah, we're going to have to run it from your side.
Okay, not a problem. Let me just do that right now.
Oh boy, I need to get it now.
No problem. So this is where we were. I'm assuming we're supposed to be here.
With the next slide. Yeah, okay, this is where I am now. Okay. Is there a way you can control for moving it forward, can you?
What was that?
So I guess you'll have to advance the slides from there.
Yeah, that's fine. Just let me know, or I'll listen and sort of,
Okay.
Yeah.
So anyway, these are the four measures that we talked about. I'm going to go through each of them as we move through the presentation. So Becky, let's go to the next slide. This is the top where we talk about software productivity is a basic measure of productivity based on the labor-based productivity measures we've seen all over industry. We're looking at the size of what's being produced divided by the total effort. In software, we typically do that with the next release. Becky, go ahead and hit the next click. So for the rest of this presentation, I'm going to talk about productivity at the release level, which means for each release, we'll be looking at a productivity figure. And we'll look at the size of software. Now, Once I've got some software in place, we're doing mostly maintenance and enhancement work. I'm developing some new enhancements to add in. I'm modifying some existing code. I may be deleting some of the code that's already there. And so I need to be able to give credit, because I could modify a lot of code and not change the actual size, and then we've got all that effort with zero size, and it looks like we did nothing. So we need to be able to go in and measure these the amount modified, the amount deleted, to really get a sense of what was accomplished with the work done. So release productivity is going to be the size of the software that was worked on divided by the total effort expended on that release. Next slide. So there's three measures that have, three classes of measures that have been proposed for doing productivity measurement, or at least doing productivity sizing. The first are requirements-based measures. For instance, use case points, which have been used primarily with UML and high-level design languages. They really haven't become widely used. There's a lot more development needed before they could become a standard way to evaluate size and use that in productivity analysis. People in the Agile world often use story points. The problem there is there's not a standardized definition of what it is, and each team develops their own way of coming up with story points for it being able to estimate the amount of number of stories, the amount of work they can actually get done during a sprint. So that tends to be fairly subjective to the team, and therefore it's difficult to compare even across teams in the same organization unless they've done a lot of work to try to standardize the way they create story points within the organization. It would be very difficult to benchmark story points across different organizations. So that's been some of the problems with requirements-based measures. Now, the most common measure used historically has been lines of code. It's a hotly debated topic. There's lots of problems with lines of code. Number one, there's no standard definition of what it is. And in fact, Capers-Jones, for instance, has shown a range of definitions that can vary by a factor of 10 in terms of the total counts you get. And I've run experiments where I gave people just a short program and said how many lines of code, and we literally can get a factor of 10 difference in the number of lines they come up with based on what they consider a line of code. Is it a physical line? Is it a logical line? Is it where a delimiter is? Do you count data declarations? Do you count blank lines? Do you count the little squigglies? There's all kinds of issues that come into that. And so it only works if you've really spent a good deal of time standardizing exactly what a line of code is. But even then we find that often smaller programs are better. I can create a large program because I didn't really understand what I was doing. I didn't use good software engineering techniques. I created a complex monstrosity. It's large. It does the job, but it does it in a very complex way that's difficult to maintain over time. So smaller programs are often better programs, and that would then create a problem with productivity analysis. So the final, and Becky, go ahead and click the next one up. The final proposal has been function points created by Al Albrecht and IBM back in the mid and late 1970s. It's become very popular in IT. There's been a number of different ways of counting function points that were proposed. The most dominant has been the one that's maintained in the guidelines created by the International Function Point User Group, and they maintain that. They certify people as licensed function point counters. There's other various ways of going about counting function points that try to solve different kinds of problems. But this has been a fairly popular approach in IT because it deals with the functionality being delivered with the user, not so much the lines of code, but the actual functions the user sees based on the kinds of inputs and outputs that are going to be produced by the system, the kinds of data that's being managed by the system and the files and what have you. So it really looks more to a functional measure, which is hopefully in the long run the economic value received by the customer. This is what we went after when the function points is what we worked on, the IFPUG-based function points to create the standard for OMG, since that seemed to be the most popular definition. It mirrored the IFPUG definition. It's not the exact definition because we had to resolve some ambiguities. Therefore, we're as close as we could be, but still making sure we could automate the entire process. But at least with automated function points, we get a consistent count that over time will be much cheaper because it's automated. Next slide. Okay, the weakest link in effort measurement is not the measure of size, even if you're using some of the hotly debated measures like lines of code. Because at least if you can standardize the definition, Becky, go back a couple. Just one, yeah. The problem is the weakest link is typically effort. Go ahead, yeah. The problem is we often get our effort estimates
Well, Bill, you cut out. I don't know if you can still hear me, but your audio is gone.
The problem is that these are often recorded well after the time the work was done, so people are trying to remember how much time they spent. They may be working on several different projects at the same time, so now they're time slicing. They're trying to guess how much time they spent on each different application. There's inconsistency in how different people create or remember their time. So typically when we have after-the-fact estimates, at best they're on a weekly basis. They may even be on a monthly basis. It's great if you can record it in a tool like Microsoft Project, a lot of our time cards. Frankly, the most accurate effort estimates, effort data I've seen was people working on government contracts where they had to record their time by law on time cards every day. But so typically, after-the-fact estimates aren't as accurate. Now, second problem, Becky, click the next one up, is consistent and intentional underreporting. People have a limit on the contract of the amount of hours they're spending, so they're underreporting so they don't overrun the contract limit. Or they're an outsourcer and they only want to charge a certain number of hours, so they never actually record all the hours they worked. I've been on the contract or an outsourcer site where they recorded 40 hours a week, and I said, but everyone's up here at 9 at night. Sorry, we only work 40 hours a week. Well, okay. But that was for a very particular reason, the way they wanted to show time for billing. So that's underreporting is a real problem. Becky, not yet. The problem being then that while it may be for a specific purpose in billing or working with the customer, the fact is you never have accurate data in which to analyze productivity or to really understand what's controlling your ability to improve it over time. Next click. And finally, there's a real problem with lack of normalization. For instance, what roles are included? Are you including the project manager in your time? Are you including your QA people, your quality assurance people, your testers? If there's a person involved in improvement or a measurement program, are you including their hours? What's actually included? Second, what phases are included? Are you including the requirements phase or not? Are you including testing or not? User acceptance test? And then finally, an hours per person here. If you have a project that is or you're trying to compare projects that are being done in different countries, I found that different countries can have quite a bit of variance in what they consider a full person year. For some, it may be 2,000 hours. I've seen even some where it was only 1,600 hours. So that can create a pretty good amount of variance. So there's all these different kinds of issues in effort measurement that we've got to resolve if we're going to be able to do effective productivity analysis. Because if we're underreporting hours, if we're guessing at hours, if we haven't normalized what was into accounting for those hours, then the variance is going to make a mess of the entire analysis process. The next slide. So it'll be unreliable and inconsistent. Now, we assume over time, back one, Becky. We assume over time that productivity is a stable number. That I set a baseline, and that's going to be my productivity for the rest of time unless we make some improvements. But there's a problem with that, and that's a bad assumption. Next click. The problem is that productivity degrades over time. It degrades because the software degrades over time. As I continue to make enhancements, as we add new defects into the system and don't get them fixed, then I've got problems sitting out there in the code. There was a study done way back in the early 1970s by Manny Lehman when he was at IBM, where he developed a notion called software evolution. And Manny's point was, look, software left to its own devices will degrade over time as you continue to modify and enhance it, unless you take specific actions to remediate the problems that you're putting in when you continue to change it. So next click. So the bottom line is that we'll see a continuing decrease in productivity based on continuing modification, continuing degradation in the architecture, in the design properties of the various components in the system, and the new defects that get injected in the system that we have to go back and fix. So next click. Bottom line is that unless you do something about it, the productivity will not be a stable number. It will consistently decline over time. So to keep a stable baseline, we're going to have to consistently take actions to remediate the problems we create in the code. Next slide. So let's look at this notion a little bit more deeply. The notion of carry forward rework, where I've got a release, let's say it's release number N, right? I've got the development work that I put in, and I've got some rework, because when I did this development work, I made some mistakes, I injected some defects, and I had to go fix them. I mean, maybe we had some failed test cases, so I went back and fixed those defects. Now, I probably didn't fix all the defects. Some we may have deferred on purpose, and some we may not have detected. Some may be structural. We didn't even analyze the code for the structural problems that we're moving forward. So the fact is there's some amount of unresolved defects, unfixed defects that I'm moving forward to future releases. Next click. So in release N+1, I've got the development work I'm going to do there. I'm going to add some enhancements or modify some code, might delete some. I've got the rework involved in this new work I'm doing, plus I've got the rework I'm carrying forward from the previous release for defects I didn't fix there if I decided I would defer that work to a future release. So next click. And since I'm going to make some mistakes in some of this new work I'm doing, right, I may be passing forward some unfixed defects from release N, from my old release that I didn't fix in this release N+1, plus I've got new defects I injected in release N+1, and all that's being passed forward to release N+2. So next click. So this will continue on release to release to release, that I'm passing forward rework from old releases. In essence, that's rework that should have been fixed back in the old release. Anything dealing with that should be charged back against release N. It was created by work in release N. I just chose not to resolve it there, and so I pass forward that rework, which means that I'm really, in a real sense, productivity is declining over time because I'm forcing myself in the future to do work I should have done back in the past. So next slide, please. So let's have an additional productivity measure we'll call quality-adjusted productivity, where I'll look at the release productivity of the current release, but I apply an adjustment factor, which is a function of the technical debt. For those of you not familiar with technical debt, it's a concept created by Ward Cunningham back in the 90s, who's one of the leaders in the Agile movement. Ward's concept was, look, you're going to create mistakes, and you're going to move some of those forward. Design decisions that you knew weren't optimal, that you had to fix in the future, so you created a technical debt that you're going to have to go and repay in some future release when you go back to fix it. Steve McConnell expanded that, saying not only is it conscious, but there's also unconscious technical debt, mistakes you made, functional defects, structural defects that you weren't aware of that are sitting out there you're going to have to fix when you discover them in the future. So technical debt is all the things that I made a mistake in now, either structurally or functionally, that have been moved out to the future that I might fix. If I'm not going to fix it, on that debt in the future. But if I do have to fix it, that's technical debt. We need to adjust our productivity because I can be extremely productive now by not worrying about fixing any mistakes, and I can just leave the next release to have to own that problem. But if I'll be a bit.
We're having some trouble with your audio, Bill.
Are we having a problem?
Yeah, you're cutting in and out. Is there a chance you could use your microphone?
No, unfortunately.
Okay. All right. Well, it sounds like it's better now, but okay.
Okay, I'll try to adjust it here. Okay, so next click, please. So we ought to adjust release productivity for three factors. One is the functional defects that were added in this release that we're going to shift forward to future releases for fixing. So that's effort in the future that I should have fixed this release. The same thing with structural defects. I'll be moving some of those from reliability issues, security issues, into future releases that I should have fixed in this one. And finally, there is the fact that if I didn't do a good job of constructing the code, I may have put a maintainability nightmare out there, unnecessarily complex code, things that just make it hard to work with the software in the future. And so I've made it less maintainable by decisions I've made and the way I've coded in this one, and that's going to affect future productivity. It'll make it harder to make changes. So I ought to have to reflect some of that damage in my current productivity estimate. So next click. So let's think of a quality-adjusted productivity factor that looks at these function points, or what we'll call enhancement function points, because the notion of enhancement function points is it also gives you credit for things you've modified or deleted that didn't change the overall function point count but did represent significant work done. And I divide that by not only the effort I spent in this release, but an estimate of the carry-forward effort for the functional defects I'll have to fix in the future, and the structural defects I'll have to fix in the future, and the effect on maintainability. Now, these are going to have to be estimated, and in the white paper I've produced, which you can get a copy of, we talk about some ways to develop these estimates. So we can have some estimates that we use to adjust productivity to see what is the effect on future productivity based on the quality of what I'm producing, and I adjust productivity down based on that if I've not done a great job of building these components. On the other hand, the nice thing is that I've actually remediated a lot of existing defects, and I've done a really good job. I may actually boost my productivity for this release if, in fact, we've moved forward better code than we received at the beginning of the release. So, in essence, the notion here is that productivity ought to be considered not only just as effort and function, or effort and product, but also we need to also look at it as a function of how quality is going to affect productivity across all of our future releases. Next slide.